Alright, the first questions that you have in kinematics defining motion that we're going to cover is the one that goes from the home to the schoolhouse. So a student on her way to school walks 4 blocks east, 3 blocks north, and another 4 blocks east is shown in the diagram. By looking at this, you have to know the difference between distance and displacement. So distance is the actual length that you travel and walk. Displacement is the total length traveled from one point that you start at and one point that you finish at. So if I look at the distance here, the total is going to be 4 blocks plus 3 blocks plus 4 blocks. All I have to do, though, is pretty much to find the displacement. It's going to be from my starting point to my ending point. So this line here is the displacement line. So then you have to compare, well, I can measure the length of each one of these. I can measure the length of from start to finish, and I can measure the length of the 4, 3, and 4. And when you do that, you'll see that compared to the distance she walks, the magnitude of the displacement is going to be less than the actual distance that she traveled. So for number 1, your answer should have been 1, that it was less. Okay. The next question we're going to do is question number 2. It says a motorboat which has a speed of 5 meters per second in still water. So we have one velocity of 5 meters per second, is headed east and crosses a river flowing 3.3 meters per second is south. So what is the magnitude of the boat's resultant velocity with respect to the starting point? So that means that we're pretty much looking for the magnitude of whatever the two vectors are. So we're going to start with one vector. One of them is going 5 meters per second in still water, which is headed east across the river. So we're going to just have one going east, and this is 5 meters per second. And then the next one is 3.3 meters per second flowing in the south direction. Okay. So we know that the resultant vector, it should be in a direction that's traveling in this direction here. But it does not ask for the overall direction in this question. You just have to find the magnitude. So to find the magnitude, all you have to do, connect the points. You don't really have to move any of the arrows around or anything like that, because the magnitudes are going to be the same. And because it doesn't have to talk about direction, you don't have to do that for this question. So we're trying to find the magnitude of this line, which means all we're going to use is Pythagorean theorem. So we have 5 square plus 3.3 square, and that's going to equal the square root of your answer. So 5 square plus 3.3 square, and take the square root, that means your answer is going to come to around 6 meters per second. So your choice should be number 3. Okay, so this is question number 2. Question number 3. Number 3 says, a speedometer in a car does not measure the car's velocity because velocity is a, and the answer choice that you should have chosen is that it is a vector quantity and has direction associated with it. So if I just have 30 miles per hour, this is just a speed, and it's not a vector because it doesn't give me any direction. But if I have 30 miles per hour east, now I have a magnitude, which is my speed, and I also have a direction to where it is going. And that's what makes this a vector. And that's why vectors are represented by arrows to tell you what size it is and what direction that it's going in. So your answer for that choice should have been 1. Okay. section we're going to do is the graphing section that I have, because a lot of it covers most of the questions that if you would have chosen them, kind of covers the same thing. The first thing that you're going to have is you're going to look at the actual graph here. You have to determine what the scale is. So all you have to do, right, is measure your scale here. Alright, so if you measure the 1.5 meters per second that's here, you're going to find that it comes out to about, I think it was 7.5 centimeters. So that means for every 1 centimeter, for every 1 centimeter, you're going to get 0.2 meters per second for number 9. So this should be your 0.2 meters per second. Let's write that down. So for number 9, you should have 0.2 meters per second. For number 10, on the diagram above, you're going to use a protractor and a ruler to construct a vector to represent the resultant velocity of the airplane, and you're going to label that vector with R. So we're looking at the resultant vector between the two, and so that means that you're going to connect these two, and we know that the overall direction is going to be towards the northeast. So if I'm adding these two vectors together, that's the direction I'm going to move. Once I find the resultant vector, though, I have several things that, if I know that it's in the northeast, I can move this arrow up here and be able to connect from tip to tail, and that's going to be in the direction of where it's going to be found. So, and that's just one easy trick in order to do that. So that's going to be question number 10. You have your 7.5, and I'm not going to draw mine to scale. I'm just going to kind of show you. So you should have your 1.5 meters per second, which is in this direction. And what you want to do is you want to take that from the bottom and move it up to the top. And that way it's located here and connected to your 0.7 meters per second. And that way, when you construct your resultant force from tip to tail, that resultant direction is going to be in the correct direction. And that way you don't really have to use a protractor for this, but if you wanted to, you would just connect the two ends, and whatever that angle is going to be the same angle that you take off of the x-axis to make in that direction. But once you have this direction here, then you've created your vector, and all you have to do is measure it and make sure that you use the scale, which was your 0.2 meters. And so for question number 11, you should have got somewhere around 1.7 meters per second in the northeast direction. So, and for question number 12, all you had to do is measure the angle. So you can measure the angle from an origin on the x that you would have here, measure this angle, same thing that you would have done if you created the resultant force here, and you would have been able to find that your angle was 65 degrees. And that's it. Alright, the next question I'm going to do is question number 16, which is because it's really good vocabulary to make sure that you know. Which of the following of these would be considered a vector quantity? And so remember, vector quantities have to have a size and it has to have a direction, which would be displacement. So displacement has the size based on what we did before when we were going from the home to the school, and it also has a direction of where you started and where you ended. So 16 would be a vector quantity. All the rest would be considered scalars. Okay. And so that's pretty much it for defining motion that I'm going to do, because most of the stuff that we do in the upper part is kind of the same thing. Can you determine displacement? Do you understand pretty much the vector resultant forces? And that's pretty much the basics that you would need to know. So you're not going to have anything really over exerting on your LEOCT.